Hey everybody! In this video we get into some application and talk about solving a distance rate time problem using a system of linear equations. So I'd actually like to go over this one first. This problem has to do with the equation distance equals rate times time. That's an important equation to know and to remember. And now let's go ahead and read the problem. Two cyclists leave towns that are 150 miles apart at the same time and travel towards each other. Okay, take one sentence at a time. So here we are. We'll call this town A, and we'll call this town B. So the distance from town A to town B is 150 miles. Right? Okay. Now, I'm going to say, well, we have one person traveling this way. Let's let them be X. And then we have another person traveling this way. Let's let them be Y. One cyclist travels 7 miles per hour slower than the other. They meet in 3 hours. What is the rate of each cyclist? So I'm trying to find the rate for each cyclist, right? That's my question. I know that the distance they travel is going to be 3 times their rate. So I'm going to let X be the rate of the slower cyclist, and I'm going to let Y, because the distance Y travels is going to be 3 times Y, that's going to be the faster rate. Now I know the total distance for the green person is 3x. The total distance for the person in blue is 3y. And that if I add up their distances, it's going to equal 150 miles. And then I also know something about the rate of y. The rate of y is faster than x, right? So the rate of y is going to be x plus 7. So now I have right here a set of 2 equations and 2 unknowns. That's all the information I need in order to be able to solve for x and y. And I can do this with substitution because y equals x plus 7, so I can go ahead and plug that y into the first equation. So we'll get 3x plus 3 times x plus 7 equals 150. Let's do some simplifying. Distribute this 3 in, so I get 3x plus 21 equals 150. So I end up getting 6x plus, let's just subtract 21 from both sides. 6x equals 129. Divide by 6 and I get x equals 21.5. Now remember, what was x? Well, x, I wrote that here, is the rate of the slower cyclist. So the slower cyclist is going 21.5 miles per hour. And the faster is going how much? Well, the faster I know is going 7 miles an hour more. So I'll take 21.5 and add 7 to get 28.5 miles per hour. So that's one example or one type of problem that you might see that involves distance equals rate times time. let's talk about this problem. Flying against the wind, an airplane travels 3,400 kilometers in 5 hours. Okay, remember, distance equals rate times time. So if we're flying with the wind, there's the same plane that travels 2,760 kilometers in 3 hours. So if we're flying against the wind, we're going to be slower. If we're flying with the wind, we're going to be faster. So keep that in mind as you think about what your final answer is going to look like. What is the rate of the plane in still air, and what is the rate of the wind? So let's go ahead and let x be the rate of the plane, and let y be the rate of the wind. Remember, we have distance equals rate times time. So the distance that the airplane travels against the wind is 3,400. That's going to equal its rate, which we haven't figured out yet, times the time, which is 3 hours. Now, when we're going against the wind, the rate is going to be the rate of the plane minus the weight of the wind, because the wind is pushing on the plane. And I messed up here because this plane travels for 5 hours against the wind. So the time should be 5. Now, the next time this plane flies is it's flying with the wind. It's going a distance of 2,760 kilometers in 3 hours. So my total distance is 2,760. That's going to equal my rate. Let's figure out the rate in a minute, times my time, which is 3. The rate here, if I'm going with the wind, I'm being pushed by the wind, so the airplane's going to be going faster. So I'm going to take the rate of the plane and add the rate of the wind. So now what do I have? I have 2 equations, or a system of equations, and 2 unknowns. How am I going to solve for these equations? Well, I have both of these equations being multiplied by 5 and then multiplied by 3. So on the top, let's divide by 5 on both sides. And on the bottom, let's divide by 3 on both sides. So I end up getting a new set of equations. 680 equals x minus y. And 920 equals x plus y. If you're wondering where that came from, let's go back for a minute. The 5's go away, the 3's go away. They don't go away, they go to 1. And then 3,400 divided by 5 is 680. 2,760 divided by 3 is 920. Now, just like when we were solving systems of equations with addition, if I add these 2 equations, negative y plus y goes to 0. Right? So that's 0. So I end up getting 680 plus 920 is 1,600 equals x plus x, which is 2 x's. Now I divide by 2 and I get the rate of the plane, or x, is equal to 800 kilometers per hour. And make sure you understand that x, we labeled it in the beginning, is the rate of the plane. Now, I can go ahead and plug this rate back into this equation here to get y. 920 equals 800 plus y. So I subtract 800 from both sides, and I get y, or the rate of the wind, the speed of the wind, is 120 kilometers per hour. And that's the rate of the wind. So this is how we do distance, rate, and time problems with systems of equations.